This is going to be the lecture on how to perform a simple linear regression. It uses the same data set that was in the correlation video. Essentially, we have participant ID, people's levels of social anxiety, rejection sensitivity, depressive symptoms, and disgust sensitivity. These are all measured on 1 to 7 scales, where higher numbers indicate more of whatever the personality construct is. So more social anxiety, more sensitive to rejection, more depressive symptoms, more disgust. So we use linear regressions, simple linear regressions, when we have one independent variable and we want to see if it successfully predicts another outcome variable, a dependent variable. So the way we'll do this is we'll go to Analyze, Regression, Linear. There are lots of kinds of regressions. This is just for the simple linear regression. We'll see we have dependent box and an independent box. We're going to take our, in this case, let's see what predicts depressive symptoms. And we'll put that in the dependent. And then let's take rejection sensitivity and put that in the independent. This would be testing to see if one's rejection sensitivity predicts depressive symptoms. All we're going to do next is hit OK. Now we're going to have a bunch of windows that appear, a bunch of boxes. The first box lets us know what variables are being used to predict what variable. In this case, we can see that level of rejection sensitivity is being used to predict the dependent variable amount of depressive symptoms. We can next go to our model summary and our ANOVA table. The first thing we should probably look at is the ANOVA table. The ANOVA table lets us know if our model is a significant model. If the model isn't significant, nothing else matters. What it means for a model to be significant is, are the predictor variables, in this case only one variable, rejection sensitivity, a good predictor? Are they good predictors of the outcome variable, in this case depressive symptoms? We determine that by looking at the significance value of our model. In this case, our significance value is 0.029. This is less than alpha, 0.05. Therefore, the model is significant. We would report the model significance as F, parentheses 1, 16, our degrees of freedom, equals 5.759, our F value, comma, P equals 0.029, which is our P value, our significance value. We can go back up to our model summary. We can look at our R square. In fact, we're going to actually look at our adjusted R square. If you multiply the adjusted R square by 100 and interpret this as a percentage, this gives you the percentage of the variance in the dependent variable explained by the independent variable. In this case, we would say that 21.9% of all of the variability in depressive symptoms can be explained by one's level of rejection.